Hello, my lovelies. It is Miss Lloyd here bringing you modeling with linear equations. Modeling with linear equations. So whenever we're doing this, these are all word problems. When we're doing word problems, here are some of the key phrases that we use for each of the different, um, you know, functions that we do in math: addition, subtraction, multiplication, division, and equality. So if we're saying something is equal to something else. There's also a lot of formulas that come along with a lot of these word problems. My students get to keep these formulas with them. I make a formula sheet, so these are all on the formula sheet, or they'll be like right next to the problem, or saying like using this formula, and then continues with the word problem. Um, so I've already written down a few of those in here for each of the problems, depending on what's going on, if it requires a formula. Some of these don't require a formula. You just kind of have to logic your way through it. And these are keywords. So for this first example, they want us to describe a strategy for solving and then solve the following problem. So tuition payments make up 67% of a college student's annual income. So 67% of their income is being taken away by tuition payments. If the student pays $8,375 for tuition in a single year, okay, that has to be community college because universities it's way more than that, or at least when the ones I went to. So they pay that much for tuition in a single year. So nice. What is her annual income? So I'm gonna highlight my keys. So I know 67% of her total income is made up of the tuition payments, and I know the tuition payment is 8,375. So in order to find 67% of something, I would multiply that something by 0.67. So I'm taking her income. I don't know what her income is, so I'm going to say I is income. And typically, anytime we're doing a variable, you want to say what it is. So I is income. So if I want to find a percentage of this, then I would multiply it by that decimal that represents the percentage. So in order to find this amount of her income, I'm multiplying it by the 0.67. So, and I know that the 67% is going to be her tuition. So the 8,375. So multiplying, getting that 67% is going to give us her tuition. And then I need to solve for the income. So in order to get rid of that 0.67, I would divide it over. They're multiplying right now. And so that 8,375 divided by 0.67 is going to give us 12,500. And of course, we want to make sure we're labeling. So we've got dollar bills, yo. And then off to the side, I would just say, her annual income is that much. And that's it. We're done. This one's the quickest. And this next one is a bit of a doozy, but it'll be all right. I'm holding your hand through it. So you invested a total of 5,000 pounds, and I'm using pounds because I'm teaching in England, and I'm teaching at an American school in England, so I just like kind of bounce back and forth. So forgive me or don't, it's kind of not my problem. So you invest a total of 5,000 pounds at 2.5% and 3.5% simple interest. So basically, I saw simple interest and I was like, okay, I know I'm going to use a simple interest formula. So I've already written down the what each thing represents. And so my simple interest formula is I is equal to the principal amount multiplied by the interest rate and multiplied again by the time in years. So I saw simple interest, and I know I'm going to use that simple interest formula. So during 1 year, the two accounts earned 151 pounds and 25 pence. How much did you invest in each account? So here I'm trying to figure out two different things. I'm trying to figure out how much I invested in the first account with the 2.5% and how much I invested in the second account with 3.5. So I'm going to end up with two equations because I'm trying to find two different things. And so I know how much I was going to put into both, but I don't know for each one. So I don't know my first principal or my second principal amount. I don't know either one of those yet. They did tell me, though, my interest rates. So for one of them, I had 2.5. For another one, I had 3.5. So those are my R's, my interest rates. And they also told me that during 1 year, that's the wrong color, during 1 year, so I've got my time there, I've got 1 year, the two accounts earned a total of 151 pounds and 25 pence. So that 151 is talking about both of the interests gained together. So a total of both of them combined is going to give me that 151. So I don't know exactly how much I got from either one. So I'm going to say this is interest one and interest two. So I don't know how much interest I got from really either of them, but yeah. So this is why I have these two because now I have two variables that I'm looking for. I don't know the interest. I don't know the principal. I do know a bit about them though. So I do know that my two principal amounts, so the P1 and the P2, together give me that 5,000. And I know that my interest one and my interest two combine to give me that. No, that's not 8, that should be a 5. So they combine to give me this. So one thing I want to do is I know I want to solve for or get rid of some of my variables. So I know that the two interest rates put together should equal that 151. So I'm going to set 151.25 equal to my two interest stuff. So I have the principal amount 1, that rate was 0.025. We always use the decimal amount when we're doing this. And then the time was 1, so I don't necessarily need to have that written down. And then we're adding in the second. And that principal amount had 0.035 as its interest rate. And so we're adding these two together. I still have too many variables. I have P1 versus P2, so I'm going to get rid of one of those by solving for one of them over here. So I'm going to move this around a little bit. So I'm going to solve for my P1. I'm going to move this P2 over P sub 2. So P sub 1 equal to 5,000 minus P sub 2. So if I take the principal amount away of the second from that 5,000, then I know what my principal amount for the first one was. And so I'm going to replace my P1 here with that. It's not going to be the prettiest thing in the world, but it's going to get the job done. So from here, I'm going to do some distribution, use my calculator with some of these decimal points, and I'm going to solve for P sub 2. So I can combine my like terms here that I have with my P sub 2's. So 0.035 minus 0.025. I can also subtract this 125 over. And the last bit is just to divide by my 0.01. And that'll give me the first principal amount, which would be 2,625. So in the account that had the 3.5% interest rate, I had originally put in, and forgive me for my pound sign because I don't think it's the best, 2,625 pounds. And now I just have to figure out the other. So remember, I had a total of 5,000 pounds. So if I had 5,000 pounds, then I can just subtract what I took in the second account to figure out the first account, which will end up giving me 2,375 pounds. So my 2.5% interest I had originally put in, we want to make sure we have our units there, so pounds, British pounds. And for the 3.5% interest rate, and we're done. It's a little bit of a doozy, but not impossible. Our next bit, boat travels at a constant speed to an island 14 miles away. It takes half an hour to travel the first 5 miles. How long does the entire trip take? So we are talking about distance and speed and time. So I know I'm using this distance is equal to rate times time situation. So I know I'm going a total of 14 miles. We want to know how long it took the entire trip. So in order to figure out how long the trip took, I need to figure out my rate. They don't tell me my rate to begin with, but they do tell me that in a half an hour, I went 5 miles. So that will tell me the rate. And it does tell me that I went a constant speed the entire time. So whatever my speed is to go 5 miles in a half an hour, that's going to be my same speed for the 14 miles, the whole 14 miles. So the first thing I can do is I know my distance was 5 miles. I don't need to have that miles there quite yet. I don't know the rate, but I know that it took me half an hour to do it. So 0.5 here. And so dividing this over, I can figure out my rate. And so it looks like we're going 10 miles an hour. Now that I know I'm going 10 miles an hour, I can use the same situation for my 14 miles. So I know we're going a distance of 14 miles. I know we're going at a rate of 10 miles per hour. And now I just need to figure out how long it's going to take us to get there. So I'm going to divide my 10 over. 14 divided by 10 is going to give me 1.4. And we've been using hours this whole time, so it's 1.4 hours. I don't know the last time I told someone it was going to take me 1.4 hours to do something. So I know I have 1 hour here. And then in order to figure out our minutes, I'm just going to multiply 60 minutes, that's how many minutes we have in an hour, by 0.4. So 60 minutes times that 0.4 of an hour tells me that it's 24 minutes. So I've got 1 hour and 24 minutes that it'll take us to go 14 miles. The next one, I've already kind of drawn this up. I'm a visual person, so I have to see what's happening. You measure the shadow cast by a building and find that it is 55 feet long. I did find out that I can do this with my iPad using the Measure app, so that's pretty cool. When you measure the shadow cast by a nearby 4-foot post, so we know our post is 4 feet, and we find that the shadow is 1.8 feet long. We want to use this to figure out the building's height. So because the sun is in the same place for both of these situations, we know that the shadow and the heights are going to be proportional. And that just means that my height of my building, so I can say H, and its shadow is going to be proportional, or we can use that fraction, to the height of the pole and the pole shadow. So we can use this to solve for our height. And anytime we have a fraction equal to a fraction, I call this the butterfly method. Others will say cross multiplication. So I've got 1.8 times the height. And that's going to be equal to 4 times the 55, which gives me 220. And so I'm solving for h, I'm just going to divide. And the height of the building ends up being 122.2 feet. Next one, a rectangular family room is 3 times as long as it is wide. So 3 times as long as it is wide. That means that I'm definitely longer, and I'm basically taking 3 of my widths and putting them together. So I can say that my length is 3 times W, and W being my width. And then it also says that its perimeter is 112 feet. So remember, perimeter is when we add up the sides of our shape. So perimeter is 112 feet. So that means if I'm finding the perimeter, it's equal to the length plus the length plus the width plus the width. So I know that my perimeter is 112, and I've represented my length with 3 times my width. And I still have these other 2 width. Not everything is in width, which is great because I can combine some like terms. And I can divide by my 8 to figure out what the width is, which in this case, it's 14 feet. Now it wants the dimensions, meaning it wants both the width and the length. So now that I have my width, I can plug it into the W here to figure out what my length is. So 14 times the 3 would end up giving us 42 feet. And those are our dimensions. And then my very last, they see that I have a cylindrical container. And so here, this is for a cylinder. It does talk about the volume, so I made sure to find the volume of my cylinder. And they say the volume is 84 cubic inches. It tells me my radius is 3 inches. And they want me to find the height of the container. So I've got this variable and I've got this variable here. And pi isn't actually a variable, it's 3.14, or you also have pi buttons in your calculator. So depending on what you use, you may get a couple of different answers, so maybe rounded differently. And then I'm plugging in what we said, radius of 3. And now I'm just simplifying. So I know my 3 squared is 9. And I want to get my h by itself. Right now, the 9 and the pi are multiplying by the h, so I'm going to divide the 9 and the pi over. In my calculator, I'm just going to plug in 84 divided by 9 pi. You may want to have that in parentheses so you know you're dividing by both and you don't accidentally multiply by the pi. And we would end up with 2.97 inches as our height. And that is it. So I am going to be doing a few more practices with my students, and they're going to have the practice below. If you found this helpful, please like and subscribe. If you feel like there's someone you know who could use this, please feel free to share it. Spread the love.